Good morning, friends. In this video, we are going to discuss about two types of reactors, namely boiling water reactor and pressurized water reactor. These are the basic reactors which have been used in earlier days. The purpose of both reactors is the same, that is the generation of steam. There is a slight variation in the construction of the reactors. The difference between boiling water reactor and the pressurized water reactor also we are going to see, and we are also going to discuss about the construction features of BWR and PWR and the circuit diagram of BWR and PWR, which are the important reactors used in nuclear power plant. Now we are looking at the boiling water reactor. Here the light water, look at the diagram, the light water which acts as the coolant and moderator, passes through the core where boiling takes place in the upper part of the core. See, look at this. This is a moderator. Let me show with the. This is a moderator. These are fuel rods. These long rods are fuel rods. This one is control rods, which will stop the reaction. This we know that in the previous video I have clearly mentioned about the reactor construction. How many shields are there to protect the radioactive leakage to the surroundings. So we are looking at the core where the fuel rods, control rod assembly is there. This is the thing we want. The steam generator will expand in the steam turbine. As which it will go to the condenser. The condensate will be pumped by means of feed pump, and again it will be circulated to the reactor pressure vessel. So this is the moderator, fuel rod, control rod. This is entire setup is called pressure vessel. The important point you have to note here is, in the diagram we are seeing the light water acts as a coolant and moderator, which passes through the core where boiling takes place in the upper part of the core. The wet steam then passes through a bank of moisture separators and steam dryers in the upper part of the pressure vessel. So in the pressure vessel we have the steam separators. Here we could not show the steam separator. Since the steam may contain some wet, it is not some 0.01% wetness may be there, that has to be removed before going to the another steam generator. So the upper part of the pressure vessel may contain moisture separator. That is very similar to heating. So we will be separating the moisture, since we don't allow the moisture or wet particles to get expanded in the steam turbine. That is the point we have to observe here. Whether it is a coal-based steam turbine or a nuclear power plant, the steam which is at a state of superheated condition alone or like vapor will be allowed to expand in the steam turbine. That's why then only it will carry more amount of enthalpy, more amount of heat energy will be carried by the steam when it is in the vapor state. So the enthalpy will be more, kilojoule per kg will be more. Then only we will be getting more power. Energy expansion will be taking place in the turbine and it will rotate the generator shaft. So that is the point we have to observe here. That steam at the top of the pressure vessel at a saturated condition at a pressure of 72 bar. The pressure at the top of the pressure vessel will be 72 bar and at a temperature of 278 degrees Celsius. At a temperature of 278 degrees Celsius. After expanding in the steam turbine, it will go to the condenser and return to the reactor as a feed water. Before entering to the reactor, the feed water will be preheated using the economizer, preheated, and it will be supplied to the reactors. So this is the construction feature of boiling water reactor. In the boiling water reactor, if you go in detail about the fuel rod house and fuel assembly, that is fuel rod assembly will contain 8 by 8 or 9 by 9 square array. 8 by 8 means 64 fuel rods will be there. 9 by 9 means 81 fuel rods will be used as fuel, surrounded by a square zircaloy channel box to ensure coolant cross flow in the core. These fuel rods, 64 fuel rods or 81 fuel rods, will be put up in the square container which is made up of zircaloy. So to prevent any water entering into the fuel rod assembly, that zircaloy channel box will ensure that coolant cross flow in the core. That is, there will not be any coolant cross flow inside the core. Each fuel rod is a zirconium alloy clad tube containing pellets of slightly enriched uranium-235. Each fuel rod is a zirconium alloy cladding (CLAD) cladding tube containing pellets of slightly enriched uranium-235. As we have discussed, this will be controlled by control rod. So this is about boiling water reactor. The pressure vessel, if you look at the pressure vessel, the diameter of the pressure vessel will be 6.4 meter, that is around 21 feet. The height of the pressure vessel will be 22 meters, that is 72 feet. That is like a 4-story building. The pressure vessel itself, the height of the pressure vessel is 22 meter, that is 72 feet, and the diameter of the pressure vessel is 21 feet. The pressure vessel, that is boiling water reactor, operates at a nominal pressure of 69 bar. So this is about boiling water reactor. Next we are going to discuss about pressurized water reactor. Now you carefully look at this picture. Here we don't have any arrangement, separate arrangement for steam generator. Pressure vessel, it goes to the steam is developed and it gets expanded to the steam turbine. Whereas in the next diagram, that is pressurized water reactor, we are seeing this pressurized equalizer. This is a separate arrangement, and we have separator steam generator, separate steam generator. This is the thing we have to observe. This is the major difference between boiling water reactor and pressurized water reactor. In the pressurized water reactor also, very similar arrangements are made to ensure the safety, at the same time to ensure proper steam generation at high pressure and high temperature. Whereas in the boiling water reactor we have seen only 72 bar, whereas here in this reactor we are generating pressure up to 76 bar. There the temperature is 273, here the temperature is 291 degree Celsius. Steam is generated. The fuel rod assembly here, 289 fuel rods will be there. There 64 or 81, here the number is more. The fuel rod array, the square array is more in this case of pressurized water reactor. Here also we are using enriched uranium-235, and the tube bundle is to the height of 12 feet as we have seen in the boiling water reactor. The pressure vessel is made up of steel with a thickness of 7 inch, that is 23 centimeter thickness. The pressure vessel, the thickness of the pressure vessel drum thickness is 23 centimeter. Imagine 23, that is nearly 1 foot. The height of the pressure vessel is 45 feet, that is 13.7 meter, and the diameter is 4.6 meter. So it is slightly bigger than boiling water reactors. All other constructions are very similar. So this is about the comparison between boiling water reactor and pressurized water reactor. Thank you for watching this video.